Okay, I'll begin where I left off in the previous video. We have three regions of area enclosed between the two graphs with 4 points of intersection. And what I'm going to do now is test a point from each of those intervals where I have enclosed area, plugging that point back into the factored form. That will make it much easier. So if I use negative 1.5, plugging into the factored form, I get positive, negative, 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 which gives me negative. From the middle interval, I'll choose 0. That'll give me positive, negative, which is positive. And from the third interval, I will have positive, negative, and positive, which will give me negative again. So remember, we stated over on the left that when it's positive, f is greater than g. When it's negative, g is greater than f. And that's all the information I need to set up the three integrals to solve for the enclosed area. The first integral will go from negative 2 to negative 1 and will be g of x minus f of x, or x squared minus the quantity x to the fourth minus 4x squared plus 4 dx. So simplifying that a bit, I'm going to get integral from negative 2 to negative 1 of negative x to the fourth plus 5x squared minus 4 dx. And I'm going to factor out the negative 1, leaving me with negative integral from negative 2 to negative 1 x to the fourth minus 5x squared plus 4 dx. My second integral is going to go from negative 1 to 1, and it's going to be f of x minus g of x. And simplifying that, I'm going to get integral from negative 1 to 1 x to the fourth minus 5x squared plus 4 dx. And you can see that my two integrands are exactly the same, only the sign in front of them and their limits of integration are different. In the third integral, which will be like the first, since it's g of x minus f of x, the only difference will be that I have limits of integration going from 1 to 2. And once again, simplifying and bringing out the negative sign, I will end up with negative integral from 1 to 2 of x to the fourth minus 5x squared plus 4 dx. And so I'm going to carry this on to the next page to save some room here, or to create some more room here. And again, notice that all of my antiderivatives are the same, so I'll tackle those all in one shot. I'll just have to evaluate them at different limits of integration and with different signs in front. So I'll begin that in the next video.